Hello, we're going to be continuing on with our lesson with polynomials, and this lesson is going to focus on adding and subtracting polynomials. You just went over the different parts of a polynomial, so some new vocabulary about that. And it may look like that when we have this polynomial, it's like as if it's in simplest form. So sometimes you will need to add polynomials together, and then you'll need to make sure it's in its simplest form. I'm going to be using this website to show you can also be able to add by using algebra tiles. So I'll go over a couple examples with that, and then you'll be able to see how you can add and subtract polynomials without needing to use algebra tiles. So say that you had these polynomials together. I'm going to start with b here. So 2y squared plus 3y plus 6, that's one polynomial, and I'm adding that with 3y squared minus 4. I can represent it like this, and feel free to go to this website too so you can practice with these tiles too. So I have y squared. 2y squared means I have two of these y squared tiles. 3y in here too, and I also have plus 6, so I have 6 unit tiles here. Okay, so with that polynomial, I am also adding 3y squared minus 4. So I have 3 y squared tiles, and then if you're using this website, you can represent -4 by putting those out here, and then you can click on them to represent the negative value of that. Okay, so if I have these, I'm going to combine any like terms here, and then that will give me my new polynomial. So the y squared tiles obviously can only be together with the y squared tiles. They are of the same shape and size here. So altogether, I have 5 y squared tiles. I only have 3 y tiles and nothing else from there. And then notice I have positive ones and negative ones. Well, if I put 1 and -1 together, that's what you would call a zero pair. So that's going to make 0. That would make 0, and this pair would make 0. So all I really have left is this positive 2 tiles here. This one would be canceled out, it would make 0. So what I have left over here is 5y squared plus 3y plus 2. Okay. Now, do you need to have algebra tiles every single time to make this? No, not necessarily. But notice that as you continue building with these, notice that I have this 2y squared and the 3y squared together that made 5y squared. The only thing that changed here was the coefficient 5. 2 plus 3 made 5. And y squared, that stayed the same. To make 2, it was 6 and -4, so that was combined together to make positive 2. I'm going to do one more example with the algebra tiles, and then we'll see how we can continue doing this without needing them. So, and by the way, continue using this until you feel comfortable to be using something other than algebra tiles. We have for C, 2x squared plus 3x plus 9. And then plus 9 here. And they're all positive. And now I have I'm adding -x squared minus 4x minus 6. So I'll have this x squared tile, that'll be negative. I have 4x tiles, and they are all negative. And I have 6 unit tiles. They are all negative. Oops, excuse me. Okay, these are all negative here. All right, then you can go ahead and combine them. So x squared and the negative x squared, that's going to make 0. So I'm going to take those out of the way. For these, I have 3 positive x tiles and 3 negative x tiles. So those are going to be away. So I have this together. And then I have these negative unit tiles or -1 tiles, and they're going to be matched with the 6 positive ones here. And the only thing that's left is the +3 here. So those are going to be put to the side too. Okay, so all I have left is then x squared plus -x plus 3. So x squared plus, minus x plus 3 here. Okay, let's try D without needing to use algebra tiles here. So notice here that I have 5 minus 3x plus x squared. Now it seems to be in an unusual order. So it's not going to be the standard form that we see it. The standard form of a polynomial is if x squared was in the front and 5 was in the back. The constant would be the last term there. But it's still a polynomial. Same thing with this. This isn't going to be in a different order. But I'm going to make sure to combine like terms here. I have a positive x squared, and that's the same as having a just 1 x squared. So I'm just going to put a 1 in front of that. And I'm combining that with -3x squared. So just remember again, if I'm combining 1 and -3 in there, that's like saying 1 minus 3, that's -2. And I'm left with -2x squared. That is going to stay the same. Because again, that's like saying I'm combining with -3x squared here, and this will make 0, so all I'm left with is that -2x squared. Let's continue on here. This is going to be what would make any like terms here. I also have -3x, don't forget that negative, and I have -2x. -3x is going to, if it's combined with +2x, then I'm going to end up with only a -x in the end. That's the same as saying -3 plus 2, that makes -1, and that's going to be a -1x, or -x. And then the last part, last pair that can be combined is 5 and 4, and that together, that would make 9. Okay, so see how you can use these algebra tiles to help you make sure that you are combining like terms correctly, but it's also possible to not need to use algebra tiles. Notice that the algebra tiles can only go up to x squared or y squared, and if you go beyond that, you're going to need to use different tiles to represent that. So here's an example. 4x to the 4th plus 3x squared plus 15 plus x to the 4th plus 10x cubed minus 4x squared plus 22x minus 23. So these are much larger or much more terms in this polynomial for both of them. But then we can combine like terms to create a polynomial still. This is going to combine 4x to the 4th and x to the 4th together. That's or same as 1x to the 4th. That will be 5x to the 4th power. Let's make sure that we're continuing down with our exponents. So I noticed here that there's an x to the 3rd power. That would be next. And doesn't look like there's another term with x to the 3rd. So it's just going to be here, 10x to the 3rd. I have x squared. there's 3x squared, and there's negative 4x squared. Together, that's going to make negative 1x squared. There is an x. I have 22x, but then there's no other terms for that, so that'll be by itself. And then I have 15 and negative 23 as my constants. Add those together, I should get negative 8. So that's my polynomial. And notice, if you're adding two polynomials together, you should get a polynomial in the very end. Okay, so this is going over adding polynomials. I'm going to go over some examples with subtracting polynomials. So that's further down over here in your textbook. But you'll find out that subtracting polynomials is very similar to adding. So I'm also going to show this using algebra tiles for a couple of them, but then you'll get to see how you can do it without needing algebra tiles. So we're going to subtract these polynomials, and this one has 5x minus 5 minus x plus 7. So just remember, if you have this minus, you can think of it as adding its opposite. And adding the opposite of this group means that you need to add have the opposite for all the terms in that group. So that's like distributing the negative. Okay, so how can you see this with algebra tiles, and how can you see it just algebraically? I'll show how that looks like with algebra tiles. You have 5x, oh, that's x squared, 5x, and then minus 5. So then I'll have these as negative unit tiles for there. Okay, and then I have x plus 7, so I have x, and then I should have 7 unit tiles here. Okay, so now we're saying that this is going to be subtracted this time, and subtracting means taking the opposite of these terms. So the opposite of positive x is negative x. The opposite of positive 7 is negative 7. So I'm going to make sure to change the sign for these. Then I can go ahead and combine any like terms. So I have the 5x and I have a negative x. That means that these are going to be making 0. So all I have left is 4x. And then these negative tiles, they're all negative, so they're going to be all combined together. That's going to make negative 12. So that is equal to, or let me just, yeah, it will be equal to 4x minus 12. How can you do this algebraically? How would it look like algebraically? You would have still 5x minus 5. We didn't change anything from that one. But what changes here was the x plus 7. We had to change the sign for that. So with distributing negative, it reminds us that we are adding its negative, or adding its opposite. So this is adding negative x, and this is adding negative 7. So you can write it as plus negative x, or you can say minus x, either or. But then after that, you go ahead and combine like terms. 5x minus x, that's going to make your 4x. Negative 5 and negative 7 makes the negative 12. So either or made that. Let's do that with B and with C. Now let's try this without needing the algebra tiles. Let's just focus on how it would look like if we were distributing the negative. Again, 2x squared plus 3x plus 2 is not affected by that negative. It'll stay the same. This is going to be adding its opposite. So negative 5x squared becomes positive 5x squared. Negative 2x is positive 2x. And negative 9 is now positive 9. Once you combine like terms, you should have 7x squared. That's positive 5x, and that's going to be plus 11. So 7x squared plus 5x plus 11. I'm going to be showing one last example, and you can pause and try it yourself, see if you're going to get the same work as I do, and then once you have that, then you can unpause and check. Okay, so again, this is subtracting, so I need to distribute the negative to all the terms in that group. So keep 12 plus 5x plus 14x squared. That is unaffected. But what's affected is this polynomial. 8x is now negative 8x. 15 is now negative 15. Negative 7x squared, that's going to be changed to positive 7x squared. That's its opposite. Now you can go ahead and combine like terms. 14x squared. I'm looking at the x squared because that has the greatest exponent. So I'm going to make sure to combine those first. That'll be my first term. And that's going to be combined together to make 21x squared. After that, I have x, 5x, and negative 8x. That'll make 3x. And 12 minus 15, that makes negative 3. Okay? Now, if you have it in any other order, say for example, if you got negative 3 minus 3x plus 21x, that's still a polynomial. It's just that it's not in standard form. Get into the practice of keeping this in standard form or writing your final answer in standard form. So that you can see the terms in order with the exponents being from greatest to least. Okay, so then your assignment is going to involve adding and subtracting polynomials.